If you page through your note packet, you're going to find this review. You should do it before checking it with this video. They just finished it in class. So remember when you're graphing these, you choose your t's wisely, and since this is trig, I would head one time around the unit circle at those really nice spots. You probably maybe didn't need a table for this one because it's pretty easy to plug in, but when you put in a 0 here, this is actually going to start at 0, and then cosine 0 is 2, so it actually starts up here. So I told you to put kind of a bigger dot on that initial point, because you need that and you need direction. When you eliminate the parameter, you'll get the same graph, but you'll lose both where it starts and what direction it goes. So when you put in a pi over 2 right here, you would be at a -2 and a 0. So it's actually heading this way, and I'm not going to do the whole thing. So it actually ends up going like this, whoops, and then you should have put arrows that it starts. And I saw some of you with just the circle sitting there. So make sure when you do it parametrically, you put the arrows and kind of make it clear where it started. Are we good with the graph? All right, there's not a whole lot of graphing in this chapter, but you do need a general sense of it. Eliminate the parameter. Today, you're going to be, whoop, I gotta turn my music off. When we do this today, this might get worded a little differently, so be careful with that on your worksheet. If it says to write y as a function of x, or if it says to write dy dx as a function of x, that means get rid of the parameter. So sometimes the prompts are kind of weird this chapter. It means you, like, if, I know you know that dy dx is equal to dy dt over dx dt, but there's one in your homework today where it asks you to write this as a function of x. So that means basically you have to eliminate the parameter so that you can only have y and x in the problem. So in this kind, to eliminate the parameter, I told you to use the fact that sine squared. And we've had people gone, so I am going to kind of write a lot of this out. Sine squared plus cosine squared equals 1. And solve this for sine, which would be x over -2. Solve this for cosine, which would be y over 2. You add and you square them, and you set it equal to 1, and then you get it in the standard form of a circle. So the denominator is actually a 4. You should have written x squared plus y squared equals 4. How'd we do on that one? Did you get that? All right. Or you could have read at y equals plus or minus the square root of 4 minus x squared, but you should get it in one of those two forms for your circle. Now you could do dy dx, right? Because you have it solved for y. So kind of know what that means. And now it says to find dy dx, but it doesn't say in terms of x. So we do dy dt over dx dt. There's going to be so many formulas. That's why we're going to keep kind of going back. I lost the originals. Can you guys just tell me what it was? I don't remember which was sine, which was cosine. I don't know.
X equals -2 sine t.
2 sine t. So I have a -2 cosine t on the bottom. And what's on the top? Was it 2 sine t? 2 cosine, so -2 sine. -2 sine t. These are going to cancel. If you don't see that, what might you see instead? Tangent of t. Yep. So, and then the second derivative is basically the derivative of your first derivative. So I'm going to write dy dx is equal to tangent of t, right? I take its derivative with respect to t, but I have to be a little bit careful because what did we say you need to divide it by? Dx dt, which was a -2 cosine t. Another way you could write that is all in terms of cosine, so it just kind of depends on if it's multiple choice or not. So if you don't see that, you could have a -1/2 cosine cubed t. Which one did you guys write? That one or this one? Some of each. The first one. They're both right. Anyway, it says when does the curve have a horizontal tangent? So your answer should be for t. Horizontal tangent occurs, right? When what equals 0, the derivative, which would mean the top has to equal 0. So your dy dt has to equal 0, dx dt can't. My dy dt was negative 2 sine t, so I'm setting that equal to 0, so basically sine has to equal 0. Where does that happen? At 0, pi, yeah. And 2 pi, it depends on what the domain looks like. So, and then when it says where, what do you need to do? Plug those in, yeah. So this would be at t equals 0 and pi. You have to plug them in for the x and the y. Did anyone get that far? So at t equals 0 and pi, we'd have to go plug those back in. Let's put a domain here from, let's do that, just so I don't have to do any, 2 pi, 3 pi, 4 pi, n pi. Then I would have only had half the circle. I'd had the left. But whatever, just for this question. So for the, where is it when t is equal to 0, right? We were at 0, 2, and when we were at pi, what were we at? 0, negative 2. Yeah, so 0, my guess is we could just put 0 plus or minus 2 and it would cover it all. Easy way to take care of it, right? All right, how'd we do? All right, so then the next thing we're going to do is start moving more into motion. It'll be fairly easy today because it's so similar to particle motion, but there is some new notation and some new language in here. So move ahead and we'll do part of these notes today, not the whole ones. So it says quantities such as area, volume, temperature, time can be characterized by a single number. And in math, we call those scalars. Okay, just things that you can represent with a number. But some of you in physics know that like force, velocity, direction, they can't be represented by scalars. They need to be represented by vectors. Okay? And vectors are directed line segments. So let's go draw one like this. I don't know how much background you have with vectors. Luckily for Calc 2, you don't need much. But for Calc 3, there's a ton of vector stuff. So after the AP exam, for those of you moving on to Calc 3, we might have to cover some vector stuff that got skipped. I don't know how much you cover in pre-calc. Almost what we need today, I think it's covered in geometry. So for now, it's not too bad. All right, so this is a vector. We put this symbol above it to indicate that it's a vector. It's kind of a one-pronged arrow. Its component form goes in what we call chevrons. So it's not a point. We put it in these. Those are called chevrons. You tell how far. And let's say this was 5 and this was 4. Okay? So its component form, mine would be a positive 5, positive 4. If I'd gone the other way, it'd been a negative 5. So that's its component form. That's pretty straightforward, correct? We also have what's called the magnitude of the velocity vector, which looks like this for notation. And I'm going to write equals. There's 4 different names this can be called. It can be called magnitude. So if you're asked for the magnitude of the velocity vector or the magnitude of the acceleration vector, that's the same as the norm is what they call it in Calc 3. Sometimes they call it the length, which makes the most sense with its formula, and sometimes it's called the speed. So when you're asked for any of these 4 prompts, which you won't get this one in this class, but just so you know, when you hear that word norm, you'll be like, oh, I've heard that word before. All right, all it is really, if you look at length, that's the easiest way to remember it, because all you do is the Pythagorean theorem. So it's really just the square root of 5 squared plus 4 squared. That's it. Pretty straightforward, correct? So that's just some language with vectors. We also are going to have angles that we're going to be concerned with. So when you're looking at that angle and you have to find it, how are you going to be able to find theta? Like, what would you do on your calculator? Or right now, say, what's theta? Yeah, so theta is equal to tan inverse. There's a FRQ coming up where they ask for the angle at which a diver beats the water. You have to tan inverse. So kind of remember that when we get there. Kids usually kind of forget about the angles because we're not going to work with them very much. All right, so we've dealt last year with this kind of motion. It'd say a particle moves along the x-axis or the particle moves along the y-axis. Now it's going to be getting pulled all over the place like we saw when we were graphing, like that first one we did where it made like that this way and that way and all over the place. So we're going to have all this we need to kind of be concerned about. Position, all right? Usually that's called S of t. Some books call it R of t when it goes parametric. So just so you know, just to distinguish between the two, that's where it is, okay? So that's at x of t, y of t. So you just need to plug your t in to figure out your x and your y. So very straightforward for position is what you think it'd be. Some people put it in the chevrons, some don't. So it just kind of, I'm fine either way. So is College Board, because you can't tell when you're reading whether a kid meant to have soft or hard anyway on that. So it doesn't particularly matter for position. Velocity actually is truly a vector, and we call that v of t. Your intuition should work very well for this. How do you think you're going to get it? dx dt, comma, dy dt. There's just going to be two components. So instead of just being pulled left or right, like we've had the velocity is -3, and you're like going, oh, it's moving 3 to the left, right? We're moving at a speed of 3 to the left. Now you're going to have two pulls on it. So it's the derivative of your position, comma, the derivative of your y position. So if they even ask you at what time is the particle at rest, you're used to setting the velocity equal to 0, correct? Now you just have two components of it you have to set equal to 0. Because if your velocity is like this, it does not mean you're not moving. It means you're moving at a speed of 4 to the right and not at all. So it means you're moving only horizontally. Does that make sense? So you're going to have to set, so you might want to write that on here. At rest means both. If there's a t, you have to find the t that makes both 0. This is the only time you will be at rest, is when it's not being pulled in either direction. All right? So at rest, we need both components to be set equal to 0. But if you can take a derivative, that's easy. You might also want to write it as dx dt, dy dt. It helps you understand and memorize some of the other formulas better. Acceleration vector is going to be exactly what you think it's going to be. Okay? It's how your velocity is changing, but now it's going to be maybe speeding up or going faster and faster to the right while being pulled down at a faster pace. So you have to, again, do both of them. So you do the second derivative of position, second derivative of the y position. All right? So that's about it. And when it asks for the magnitude, speed, length, or norm of either the velocity or the acceleration vector, you do the square root of squared plus squared, whatever numbers those are. All right, so that's kind of a whole lot of new stuff that's not very new. It's just things are going to be being pulled on at once. I'm not sure in physics how they, well, I don't know, you guys can let me know. So we're just going to start with an easy one. So we've got a particle moving in the xy plane. We could graph it on our graphing calculators to see how it's moving, but I don't want you to. And this is where it is at any given time. And I want the velocity vector. So I just say, well, the velocity vector at any given time is just going to be a function of the derivative of position. I just have two of them. So there's really, that's very, I love what I like about this class is everything just kind of makes sense with what you already know. And if I need to do that at time 1, I do what I did in Calc 1. I just plug a 1 in. So I just go like this, 11, comma, 1. What does that mean about the particle? It's moving faster to the right than it's moving up, correct? You don't really know until you graph it, but you should know where it starts. Like if I were to put this in my calculator, at t equals 1, it's going to be at 5, right? Comma what? 0. So it will start there. It's being pulled faster to the right than up. I just don't know if it's concave up or concave down. Does that make sense? So I don't quite know without graphing it whether it's going like this or whether it's going like this. But it's actually going like that because I graphed it. All right, but so does that get you like how it's moving? it's moving faster to the right than it's moving up. You don't need to know how to graph or really even understand the graph, but I do think it helps. All right, so if it says for what's the magnitude of the velocity vector, you would just do the square root of 11 squared plus 1 squared. What is that, 122? 122. It means what's its length? And it's the vector going like this. What do you think? Pretty easy, right? All right. So, do you guys have anything else on the bottom of that page? Yes. Now it says the acceleration vector, so your gut instinct takes over. So these are straightforward questions. We'll have some goofy ones. I think we'll save them for tomorrow. Can you guys take the derivative for me so I don't have to scroll back up? The 6t plus 8, and then 12t squared minus 6t. Do we agree with her? Yes. Perfect. And it says at time 1, so 14, comma 6. That's it. Now if I said the magnitude of the acceleration vector, I would do the square root of 14 squared plus 6 squared. The notation for it would look like this. It'd have like an absolute value bar. It is always going to be positive, and then they're double. Easy, right? I think so. So far, so good. So let's move on. You guys go do this guy. Then we'll add some curvature to it. And then we're actually going to stop and go work for a little bit on the easier part of this, just to get used to like the question prompts. Parametric usually does not cause issues. I get BCers who 9 out of 9 parametric quite often. Polar, that's a different story. And series is really hard, but parametric usually goes real well. So understand what these numbers mean because the computations are easy. At time 1, this would have been at the position 4, comma, -2. So it would have been 4 to the right and 2 down, correct? That's where it is in the coordinate plane. It's being moved to the right, right? I mean, correct? While also moving what? Down, but slower than it's moving to the right. So you can kind of picture if you were to graph that and scroll to where t equals 1 or set it to start at t greater than or equal to 0 and stop it at 1, what you'll find is that it's being pulled to the right and down from the point 4, -2. Are we good with the motion of it? Now we're going to start off with a tricky one, and this will kind of tie it all together. So you should know what this is going to make, which is why we graphed it. We graphed first, even though I know you won't have to graph on the AP exam, just help you get a visual. Especially if the question's like, where is there a horizontal tangent line? It can save you a ton of time. Do you guys know what this makes? Almost. An ellipse, correct? Pulled out 4 and up 2. So if you understand the graphing, even though a lot of calc teachers skip it because it's pre-calc, you know there's horizontal tangent lines right here and right here. And there's vertical ones right here and right here. And you can skip a lot of the calculus just because you know what it looks like. This one says find the velocity and the acceleration at pi halves. So let's go do that. So velocity and acceleration vectors. So those are functions. My velocity vector is going to equal, and they should go in chevrons, -4 sine t and 2 cosine t. Just nice and easy derivatives right there. All right. And then it says at pi halves, okay? So at pi halves, my velocity vector would be what? You guys go ahead and tell me. What would it be? -4 and then what?
0.
Now, a lot of times that's called tangential velocity because actually when we go graph it, It starts here and it's being pulled up and to the left. And when we say what's the velocity vector, we mean as if it didn't have acceleration pulling on it at that time as well. Like you'd go flying off it. Does that make sense? And then it says acceleration vector. Okay, so my acceleration vector would be -4 cosine t, comma, -2 sine t, right? I didn't make any arithmetic mistakes that were silly, did I? And then if I put a 1 in there, at pi halves, this would be 0, right? And what would this guy be? Yeah, 0, -2. Now, I'll tell you what that means in terms of the motion in just a little bit, okay? This says to find the speed. What's another word that I want you to think of for speed?
Magnitude.
The magnitude, the length, and in Calc 3, the norm. It's just the square root of -4 squared plus 0 squared, which equals the square root of 16, which means it's 4. It means if you were to go around here like this, you would go flying off this thing right here at a speed of 4 whatever's per whatever, miles per hour, kilometers per second, whatever it is. So it's actually some in advanced physics they tend to call that tangential velocity, not just velocity. It's as if you fly off on that tangent. Are we good? All right. So on our next page, we're going to draw the path of that particle. Okay. So let's write it down again. Our position was 4 cosine t for x, and our position for y was 2. Is it 2 sine t? Right? It was, wasn't it? Yeah. All right, so if we were to make our table and plot all our points, this at time 0 would be at 4, 0. So if we graph this on our graphing calculators in parametric mode, it's going to start here. We kind of already know it's going to get pulled up to here, and then it's going to, so we just graphed one, so I think we're kind of good. Then we put the arrows on it. All right, and it says draw the path of the particle to show the velocity vector. So it's coming around, and I told you it's whipping off like that. 4 left and 0 up or down. What was the acceleration though? You remember? It was 0. So nothing pulling on the x, but what's pulling on the y velocity? Wasn't it -2? That's why it curves down. It's the acceleration vector that pulls that down. Does that make sense? All right, so and again, you can find all the right numbers without knowing that, but if some of you are going into like advanced physics, which I don't know if you are, but it's good to understand the motion of it. All right, so now this says arc length. What do you think that's going to be called? I want you to think, it's going to get a new name from arc length. Arc length would be what this is, correct? What do you think it's going to be called? Think back to parametric and regular particle motion. If I said, what's the arc length, I want to know, and I don't want to say the words, I want to know that length. It's going to get a new phrase. Same formula, new phrase. Total distance traveled. Yeah. So, and now watch how you don't have to memorize all these formulas if you get it. This is AKA total distance traveled. Okay? And this just says from 0 to pi. So we're going to be doing the top half of the circle. So basically we'll be figuring out the arc length of that ellipse on the top half, which will represent the total distance the particle travels from 0 to pi. See if you've got that formula memorized. It hasn't been very long. And then I'll tell you how you already know the arc length formula. So I'm going to write total distance traveled. So you're not memorizing two formulas, correct? So you should be integrating from 0 to pi. And then it's the square root of, do you remember what's under there for our parametric arc length? Thank you. I was afraid you were going to say 1 plus. That's if we eliminated the parameter, solved it for y, Then we could get the same answer by doing 1 plus this, but we don't want to do that. All right, so we're going to do dy dt squared or dx dt squared plus d, it doesn't matter the order, so I'm just going to write it like that. Now watch this. I want you to bracket this off so you can avoid having to memorize. In our particle motion from last year, didn't we always integrate from time 1 to time 2? For total distance traveled, what was in our integrand? Absolute value of what? Velocity, correct? This right here is the speed, right? It's the square root of the dx dt squared plus dy dt squared. It is the speed. It's the magnitude of the velocity vector. That's what this is. So you are still integrating the absolute value, because this can't be positive, of your velocity. So, does that make sense? This guy right here is our formula for speed. You do the Pythagorean theorem on. Does that make sense? So you really don't need to know all 3 formulas because they're all tied together, right? So speed is in here. Absolute value of speed is velocity. Well, this is going to give you absolute value because I'm squaring, so I can't have negatives. So I'm really just doing my same formula, and it comes from the arc length formula. So they're all, if you understand it, your brain doesn't have to try to remember a zillion formulas this chapter, because there's way more coming. All right, so when it asks for total distance traveled, what formula are you going to bring up in your brain? Arc length. Or you're going to go back to particle motion. I need to integrate the speed. And you're like, oh, well, I know what speed is. It's the magnitude of the velocity. So it should all tie in and make sense. I think I want to quit there. Yep, so this is where we'll start tomorrow. On your worksheet, you might get, let's see how you do, but I think we're going to pick apart. I'm going to pass out worksheet number 4, and I want to say the ones you have to do before I turn this off. So you might just want to write down these numbers. Today, you are going to do 1 through 4. I'll just leave it up there. All right, 8, 9. What does it say? 10, 13 to 16. Tomorrow we'll finish it, but it's going to be due at the end of the hour tomorrow, so you should come in with those done or you're not going to finish. Yours will be late. My guess is, though, you can probably get at least a number 9 or 10. They go very fast. I got to clue you in before I turn off my video. If you're at home, these are attached. So I'm just going to talk you through a couple things first. You should have no problems with 1 through 4. Okay, that's very straightforward. You shouldn't have any problem with number 8 if you were listening to me. I don't have any problems today. Number 9. I want you to think that, I want you to read the question, because these aren't all monkey see, monkey do questions, like there are twists to them. So you really need to understand what you're doing. Number 9, go ahead and read it. What ingredients do we need to write an equation for a tangent line? We have the point, right? So you can even start. Y plus 4 is equal to blank times x minus 8. Okay? We need the slope, correct?
Yeah.
And it's parametric. You're nodding. So then you're going to go, okay, dy dx, dy dt over, it's not really memorizing. It's like just kind of following one lead to the next. So you're going to do dy dt over dx dt. That's easy. Those are nice, easy polynomials. And then what's missing? T. You're going to have to find it. So there's a little twist there. Right? How do you think you're going to find it? I'd use either x equals t cubed and put the 8 in for x, or if you're really dumb, choose the other one. Okay? Then the next one is number 10. You should be fine with number 10. And I'm having you skip number 11 because I didn't talk about position. 13 is a full FR field. But all of it you should know, and there's calculator permitted, so you should be good. Yeah, you should be good. I don't think you're going to get stuck much today. There is a key posted. I would try to avoid it today. These are tricky. Go ahead and start. You can get a good chunk. They go fast. The derivative